All right, gentlemen, we are live.
Yo, yo, welcome to Ether Cosmology Reading and Research Night. Tonight, we're going to get into a couple of papers that were discussed last Thursday during the debate between Alan and Shane and Mordwand and Peter. And so here we are. And without further ado, or I'll throw the quick little disclaimer on there. This is reading and research night. This is not presentation night. This is not come have a fun hoot and holler with us night. This isn't yeah, this is actually us doing research, us doing reading live on the spot. So it might get boring for some people, but the point is to, allow participation. If you want to come read with us, you can join us at discord.gg/ethercosmology. And yeah, feel free to come read with us. But without further ado, let's go ahead and dive in.
Awesome. Yeah, so in preparation for the debate, Eric helped me find a paper that gave the classical derivation for the Sagnac effect versus the derivation under relativistic principles. Only a 6-pager, but it's pretty interesting and succinct. I figured we'd knock this one out, and then we'll get into a paper that supposedly refutes Ruyang Wang's 2002 experiment where he measured linear motion with a with an interferometer. So we'll get into that right now. All right, so this is the
Please.
classical and relativistic derivation of the Sagnac effect by my boy W. Engelhardt. Abstract. Both the classical and the relativistic composition law for velocities are applied to recalculate the Sagnac effect. The ensuing formulae for the fringe shift are found to differ already in the first order of V over C. Whilst the classic formula is validated by interferometric measurements and verified by the GPS system, this is not the case for the relativistic result. Introduction. In 1925, Michelson-Gale built a huge Earth-fixed Sagnac interferometer in Illinois, demonstrating that the velocity of light is anisotropic on the rotating Earth. For Sagnac, this result did not come as a surprise, having explained the underlying effect on the basis of ether theory in 1913. Now, a quick note on Earth ball rotate, right? That's just, these are measurements, so it could be ball rotate or it could be ether rotate. Let's keep going. The special relativity theory, however, had predicted on the basis of a Lorentz transformation that the velocity of light is isotropic in all inertial systems. Of course, the Earth is not an inertial system, but due to Earth's rotation, the motion of the Michelson device was only about 2 millimeters during the passage of the beam around the interferometer. The deviation of the mirrors from a straight orbit was less than 1/100th of an atomic diameter, so that non-inertial effects should be entirely negligible. Nevertheless, the linear term x v over c squared in the Lorentz transformation, which is responsible for c equals a constant, minus, was simply not there. The experimental result was consistent with the Galilean transformation, the old GT, i.e., light seemed to have traveled at a velocity c minus v from west to east, and c plus v on the path from east to west, where v is the local rotational velocity of Earth's surface. Strictly speaking, the rotating Earth must be described by general relativity theory, but it is hard to show how a very slow rotation should invalidate the Lorentz transformation and reestablish the general theory as founded by Michelson-Gale. Indeed, Post admits in a great review in citation 4, quote, "The search for a physically meaningful transformation for rotation is not aided in any way whatever by the principle of the general space-time covariance, nor is it true that the space-time theory of gravitation plays any role in establishing a physically correct transformation. Consequently, he sticks to the classical formula valid in the ether theory, making only slight modifications to it too small to be verified by experiment." Oh, no way. Just throws in a little gamma
Wow.
factor at the end, little quadratic formula at the end there. Let's see. So in this paper, we derive the Sagnac effect on both the classical and the relativistic composition law of velocities that can be formulated for a curved light path accordingly. Oh, one second. Let me let this cat in. Come on, buddy. Calculating the ensuing travel times of light around the interferometer, we find that the Lorentz transformation, due to its linear term x v over c squared, does not predict the Sagnac effect, but results in c equaling constant also in the rotating system as it does in the inertial system. This explains why Ashby in citation 6 uses the Newtonian or Galilean transformation t prime equals t rather than t prime equals gamma, which is the contraction function for the time coordinate, which would reduce time by the function of the square of the velocity over c squared, when he calculates the Sagnac effect in the GPS system. This was also observed by Carol Alley at a comment at the end of the engineering presentation on GPS and relativity. In section 2, we derive the classical Sagnac effect for a circular light beam, and in section 3, we do the same for the Lorentz transformation. Section 4, we discuss the implications of our results. So here we are with section 2, the Sagnac effect explained in the classical framework of an ether theory. The classical transformation between inertial systems is Galilean, which reads as x prime equals x minus velocity times time, and the time coordinate will be transferred as t prime equals t. So time is absolute, and distance will change as a function of velocity. Although it is formulated only for the linear constant velocity between systems, it can also be adopted for a constant rotation by deriving a composition law for circular velocities. Considering infinitesimal lines on a circular orbit, rewrite the equation 2 as follows. And this is just describing a circle and then breaking it into infinitesimal parts where they would be essentially linear from one another. Where nu naught equals omega r is now the rotational velocity with angular frequency omega on the circular orbit, s at the radius, and s at the radius r. Dividing the time by the increments of both sides of the equation, one obtains ds over dt equals nu phi. The composition law for constant circular velocities is given by equation 3. Nu prime phi equals nu phi minus nu naught. In fact, facilitating the analysis, most treatments of the Sagnac effect consider a circular interferometer where the light beam is guided by either a circle or by a large amount of tangential mirrors or by optical fibers in citations 4 and 5. The travel time of light to complete the orbit, L equals 2 pi r, around the circumference of the interferometer is then given by equation 4, which is time plus or minus, going clockwise or counterclockwise, is equal to the length over the velocity phi plus or minus nu naught, and then the same for the other direction, depending on whether the light propagates parallel or anti-parallel to the rotational velocity. Two coherent light beams starting at the beam splitter in opposite directions return at different times, leading to a fringe shift due to the difference as calculated with equation 5. So here's the long form of it, going clockwise and counterclockwise. The linear dependence on the rotational velocity has been confirmed by many experiments, whereas the quadratic term is too small to be measured in practice. In most textbooks, the result is expressed by the fringe shift in the units of the wavelength of lambda naught. So we have the modern formalization here. Your delta z equals 4a times omega over c lambda naught. And that's your fringe displacement, your delta z. Where in general, the scalar product of the orientated area A enclosed by the light path with a vector angular velocity omega enters. One can show that the fringe shift is independent of the shape of A and of the position of the rotational axis, but depends on the cosine of the angle between the area and the angular frequency. One out now? Fast. All right. Whereas Sagnac could rotate his device in the laboratory at a variable speed in order to verify his formula, Michelson-Gale had to verify the area enclosed by the light path in order to prove the validity. So if you've ever seen the Michelson-Gale Pearson setup, it's a big rectangle, and they cut about like 15% of it off with another mirrored section. That's how they were able to change the area there to manipulate that. This experiment was important as demonstrated that the ether is not co-rotating with the Earth like the air. Apparently, the ether wind must exist due to the rotation of the Earth, which leads to the observed time difference. Any translational motion which surely exists cannot be detected by the circular interferometer, as the influence of the constant translational velocity cancels out the round trip in light. So here he's referring to the Sagnac. Can't stop. Referring to the classic explanation for the reason why Michelson-Morley, measured a quote unquote null, but obviously Wang measured it linear. Everyone's reproduced Michelson-Morley where they measure the translational speed. It just doesn't give agreement with heliocentrism, so he's looking at it through that lens. Any translational motion which surely exists cannot be detected by the circular interferometer. Sorry about that. In this respect, the Sagnac interferometer is insensitive as the Michelson-Morley interferometer, but that's not true. Whereas the enclosed area A vanishes. Although the experimental results obtained by the Sagnac interferometers are in full agreement with the ether theory as shown above, they are generally not considered as disproving special relativity theory, which postulates that C is a constant, and thus it is at variance with the ether composition law. In the next section, we will show why it is commonly held that there is no discrepancy between the classical composition law and the relativistic philosophy concerning the behavior of light. The reason is the defective application of special relativity theory. Oh, no way. Section 3, the Sagnac effect, interpreted in the framework of special relativity theory. Most textbooks assure the reader that the Sagnac effect is a, quote, relativistic effect, which incidentally may also be derived by an ether theory, leading practically to the same result. Looking closer, dude, you love how they do that. They do it every time.
Incidentally.
Yep. Looking closer, one finds, however, that a truly relativistic derivation is not really attempted. A good example is Post's procedure in section 3. He also uses circular geometry, see figure 8, which our analysis in a previous section was referring to. The stationary observer he comes up with the time difference, 7p, which is identical with our formula derived from the classical composition law for velocities. This must also hold true for the co-moving observer if Ashby's Galilean time transformation t prime to t into the rotating system is valid. Post insists, however, that the time increment between the rotating and the stationary system must transform according to this equation given by equation 11. We got dt equals gamma dt prime, where he's trying to introduce a little gamma factor here, which can also be found in the Millikan paper in citation 5. Consequently, these authors claim the correct relativistic time difference as measured on the rotating beam splitter must be from Post's equation, 23p, or Millikan's in 5m, which is our classical formula, citation 5, divided by the gamma factor. One notices that the Lorentz transformation was only applied in the mutilated form when 23p was derived, since 11p is at variance with the complete Lorentz transformation. A different conclusion is reached by employing the correct expression, i.e. by applying a truly relativistic composition for law velocities that cannot be attained from example 11p. For the case where the light beam propagates parallel to the x-axis, the Lorentz transformation reads as equation 7. In order to adapt these formulae to a curved light path, we consider infinitesimal time increments and analogy to equation 2, assuming a constant rotational velocity of nu naught, given by equation 8, where S denotes the curved light path in a rotating interferometer. This formula can also be found in Post's article 29p, where he quotes the papers from Croissant and Troche. Anyone want to take a crack at that? Trocheris? Of course, citation 8 is only justified as long as the light...
Trotere?
Couture?
Trochery?
Oh,
Trochery?
croissant and baguette. Of course.
Like, I think
Cita
French is trochery and troteret, and I think the Americanization would be, like, trochery or something.
yeah, treachery. Alright. Of course, citation 8 is only justified as long as the light beam propagates parallel to the rotational velocity, but this is ensured by the use of the optical fiber, for example, the spatial increment given by equation 9 is not given by Post, nor does he calculate the composition rule resulting from division, given by equation 10. Although not explicitly derived, this formula can be found in Millikan's paper, citation 5, as the second equation to M. He does, however, not draw the obvious conclusion if the phase velocity of light in the laboratory is nu phi equals c, given by equation 11, it follows from equation 10 or from equation 10 that the phase velocity of the rotating system is also nu prime phi equals c. This result does not really come as a surprise since it only reflects Voigt's postulate c equals constant from which the Lorentz transformation was derived and or entirely copied one to one from our boy Einstein. But derived is also a very generous word. If this transformation holds between inertial systems, it must also hold between inertial systems and systems rotating at a constant velocity, as just demonstrated. The obvious consequence of Millikan's formula 2m or uh, equation 10 above is that the coherent beams leaving the beam splitter at the same time in opposite directions will return at the same time as they both travel at the same speed, c, according to equation 12. The relativistically correct result is therefore not Post's formula given by 7p or Millikan's formula given by 5m, but simply delta t prime equals t prime plus minus t prime minus equals L over c minus L over c, which equals 0, given by equation 13. In other words, the special relativity theory, when correctly applied to a rotating interferometer, does not predict the Sagnac effect. Not without invoking absolute space and doing a little Lorentz transform there for geometrical convenience, of course. Implication of the demonstrated results. The Michelson-Gale experiment in 1925 had already shown that Voigt's postulate c equals constant is untenable. When the GPS system delivered more and more precise measurements based on the propagation of microwaves, it became clear that the Sagnac effect had to be taken into account. This implied the use of the classical formulae derived in section 2 on the basis of ether theory. Ashby drew the correct conclusion and reintroduced the Galilean transformation T prime equals T between inertial ECI and the rotating ECEF systems, given in citation 6. From Ali's remark at the end of citation 7, we conclude that the GPS software developed by engineers for providing precise precision measurements ignores the Lorentz time transformation, allowing for Ashby's line instead, which is Galilean, so absolute time and space. There are, of course, other indications voiced by Hatch in citation 9, which suggest that relativity theory should not be applied to GPS measurement. How dare you, Hatch? Peace be upon him. In light of the analysis in section 3 and the irrefutable experimental result, it is obvious that Voigt's postulate of 1887, the constancy of C in inertial systems, does not reflect the observed physical law. This was always clear. It was always clear that in the valid case of acoustics, we have no reason to adopt this for optics either, as the special relativity theory, as a consequence of its postulates, its basic tenet is at stake. Any thoughts, gentlemen?
Well well, they're talking about acoustics, but acoustics are waves, and we know that light is not just a wave, but it's also a particle that has no mass but still has momentum, so, you know
Oh yeah,
Uh, isn't it fun when you get to just use nonsense as your argument?
indeed.
But I mean, but the point at the end there was perfectly made. Like, uh, you know, in Hatch and Wang's paper, they like joke about it. Like, we don't have a constancy of the speed of sound because that's silly. Because we know that sound is relative to its medium. And I mean, it's just, oh, there is no medium though because you're in a vacuum and there's no medium. It's just massless, massless momentum. It's silly, but yeah, that was a good one. That was a pretty like it's nice, man. There's so many of those bangers. Like I feel like every time we get one of these that talk about this from a logical perspective like that, it's just like they outline it so well from start to finish. Like there are so many papers like that that just outline the problem from start to finish.
Yeah.
Um, and so many people are like, "Well, show me the paper," like, "What are you talking about relative?" It's like, dude, actually, it's kind of crazy if you just go nowadays, just go on to Google Scholar and search relativity theory, and especially filter your results by like the last 2 years and like I'm or special relativity, and it's just, dude, no one is defending special relativity these days. It is all just like, yeah, it's kind of fake, isn't it? It's kind of like, let's see what do we got.
They're just taking it out back and shooting it.
Yeah, no one wants to step up and defend it anyways.
Postulates versus observations. I bet this is
Well, so wait, what year is that from? That's 1949. No, yeah, switch to custom date range
a custom date
and do
range.
or just click since 2023. Click that.
Okay. Black
And then
holes.
do special relativity specifically. Or you did, didn't
Yeah.
try quotes around it, maybe. Oh, applied mechanics and engineering. That's actually kind of intriguing. Special relativity search for applied. But there we go. Limits of special relativity, renormalization of very special relativity, gauge theories, a unified perspective on Poincaré and Galilei relativity, experimental investigation in machine learning modeling using. Oh, well, that's kind of useless.
Yeah.
But the last time I had looked, it was pretty. It was hard to find much defending it. That's for sure.
It seems to get
Anyways,
easier and easier to find things that contradict it because everyone's kind of ready to move on.
it's tough when you just got like experimental evidence and GPS and stuff that just piles up. Like, I mean, what are
Yeah.
you gonna do?
I mean, dude, real quick, like that one dude where he's mentioning Carol Alley, 1996. There's our boy Carol Alley, who in 1979 did an atomic clock experiment similar to Heffel and Keating, and got it to quote unquote stay um, synchronized using Einsteinian synchronization method for about 16 hours, and then it didn't work anymore. But he was super happy about that 16 hours. And then here he is writing in, and he's like, "Relativity is confirmed, boys. We're gonna put it in GPS. It's super real. It's no longer just for funsies cosmological calculations, right?" And then here he is in 1996. And if one does perhaps the explicit recognition that the special relativistic effects, I mean, it took a long time to get the general theory down properly, but I think it is more or less correct now. I mean, we hope, right? But its absence of any explicit acknowledgement of the special relativistic effects due to the speed of light being the same whenever measured by an observer, leading to the relativity of simultaneity and the associated Lorentz physics, there's nothing of that modeled in the current system, and I think there should be. Thank you. Dude hit him with a TY at the end, bro. He was like, that thing we all believe in? How come it's not in GIPS? Super unlucky. All right. Now we'll get into the other paper here. All right, this is the Sagnac Wang interferometer and the absolute versus relativity simultaneity. All right. Abstract. The Sagnac effect and the role of simultaneity in relativity theory claim that the Journal of Modern Optics in 2021 claimed that the Sagnac effect reveals the special theory of relativity is incorrect and inconsistent. We prove that the standard relativity, when standard relativity is appropriately interpreted, it is observationally correct and logically sound. Well, can't wait for this one.
Oh, dude. Oh, I get it. We didn't have the correct interpretation this whole time. That's why we all thought it was retarded. It's not that it is retarded. It's that we all interpreted it wrong, dude. Oh, I get it. I understand it. Wow.
We're just too dumb.
Super dumb.
We're all the same kind of dumb, actually. Like the same brand or flavor. Exactly the same, it seems.
Introduction. The so-called Lorentz transformation have been hailed in some corners as a valid alternative to Lorentz transformations. Wait, what? Oh, an absolute Lorentz transformation. Never heard of that. Considering only the spatial dimension, the Lorentz transformation is T prime.
Isn't that an oxymoron?
Dude, it's the most oxiest. It's insane. So here we have the change factor for the time coordinate as a function of velocity squared. And the same for distance. While the absolute Lorentz transformation is given by delta or T prime over T gamma. And then we have X prime equals gamma X minus nu T, where gamma equals 1 over the square minus B2 and B equals V over C. The alleged virtue of equation 2 would be that it allows us to keep absolute character of simultaneity, which completely refutes relativity, without discussing the empirical adequacy, or without discussing their empirical adequacy. The most evident problem with the Lorentz transformation absolute is that it lacks the theoretical and conceptual support. Oh, no way. While the Lorentz transformation can be derived from clear physical principles, as was done as the first time that Einstein copied it from Voigt, the absolute Lorentz transformation is an ad hoc alteration of the Lorentz transform with the only purpose of making simultaneity absolute. We shall refrain from referring to the Lorentz transformation of absoluteness from here. We aim to prove that the theory of relativity is free from inconsistencies the Sagnac effect purportedly reveals. In reference 4, the authors analyze two versions of the Sagnac experiment, the ring interferometer and the Wang interferometer, which is linear. In both instances, we have a light source and a detector in the same position inside a moving system. The experiment purportedly reveals two problems. One, for the co-moving observer, the speed of light is different from its universal value of c. And two, time is discontinuous by a clock cannot be synchronized with itself. And a clock cannot be synchronized with itself. First issue would constitute empirical evidence against relativity theory, while the second would reveal its inconsistency. Section 2, we examined the Wang modified experiment, and in Section 3, we analyzed the ring interferometer that purportedly suffers from similar difficulties. Here we have the Sagnac Wang interferometer, the old conveyor belt, and then we have a classical ring interferometer here. We got our clockwise and counterclockwise rotations.
I can't wait to finally get it and just have it all explained to us. It's all
Dude.
going to make sense, guys.
Dude, I mean, it's only 10 more pages until we become relativists, boys.
Dude, have you ever wondered what it's like to have the correct interpretation of something? Because it sounds tantalizing.
I can't wait.
Right.
Section 2, the Wang linear interferometer. Sapaveri and others, I hope that's right, analyze the two experiments of Wang's modified Sagnac experiment. Since the problems of these examples presumably reveal are very similar, we only re-examine here the first example given in reference 4. Following a similar approach, all calculations are simplified to the first order. This means we take gamma equals 1 in all relativistic formulas, and we can neglect time dilation and Lorentz contraction effects. Dude, they're not even trying, bro. They're already opting out. Also,
Dude, we can have an absolute Lorentz contraction. Also, we can totally ignore our absolute Lorentz contraction. It works both ways, guys. We're so good.
Yeah, well, I can't say, I mean, obviously I was being sarcastic earlier. It's funny how they came right out of the gate this time. Usually they try to start setting up their geographically convenient position. They try to sneak it in there a little bit,
Yeah, like they gotta hide their retardedness so that people outright reject it, and this one's kind of outright.
Also, the time elapsed at the turning points A and B is assumed to be null. At those points, both the clock and the photon undergo infinite acceleration. Right? Sapaveri and others note that even with the simplifications within this order of approximation, we cannot neglect the term nu x over c squared in the time transformation responsible for the lack of absolute simultaneity. The objective is to evaluate the time elapsed t between the emission and the posterior reception of the photon given by phi, as registered by the clock c in figure 1b. Since the total distance covered by the photon is 2L and the relative velocity is c plus nu, given by equation 3, we shall prove that an observer co-moving with the clock c finds the same value applying relativity theory. Indeed, since equation 3 is Newtonian, the results is Newtonian results, and we disregard the second order effects. Both results are expected to coincide. This is most obvious by calculating equation 4. We have tau equals the integral of dt over gamma. Calculating over the clock trajectory since the first order gamma equals 1. However, Sapaveri and others explicitly analyze the role of relativity of simultaneity to highlight the alleged inconsistent nature of relativity theory. Do you think he would get on the train? The bomb train? Sapaveri doesn't seem like he would want to get on it, but this dude seems like he would.
I think it's a duo. Like, would you trust your own junk to the zipper that protects the vacuum to space? Also, if you answer both yes to both questions or no to both, I think it's either or.
Yes. Thus, we shall use a similar approach to Sapaveri. We start with the observation at the inertial frame S+, where the clock C is at rest. The observer in S+ sees the device moving at a speed nu from right to left, or from left to right, sorry. In figure 2b, we assume that the point A reaches the clock position at the same time photon phi reaches point B. If the speed of light is in S+ is c, the time registered by the clock is given by equation 5. Time out equals L over c. As seen from the inertial frame S0, where the interferometer is stationary, points A and B are stationary. In figure 2a, the clock C undergoes a sudden acceleration and then continues with its inertial motion in opposite direction in the frame S-. From the point of view of the observer in S+, the clock passed from the frame S- with a relative speed W equals 2 nu, given by figure 2c. We want to evaluate the time measured by the clock now in the frame S-, figure 2, frames S0, S+, and S-. Clockwise or counterclockwise? Stationary? When the photon reaches it, the rest of the clock reading 0 and use to the first, wait, we reset the clock reading to 0 and use equation 1 to the first order. The event corresponding to the photon at B when the clock is at rest, or when the clock is at A, has space-time coordinates 0, L in S plus. The same event S minus has the space-time coordinates 2 minus nu L over C squared L. Thus, according to time in S minus, the photon was at B when T minus 1 equals minus 2 nu L over C squared. It is irrelevant that the clock was not in S minus at T minus when T equals T minus 0 at once. It joins, or once it joins S minus, its time is assumed to be in synchronous with the time of that frame, and that the photon already left from that point from B equals 2 minus, or T minus 0. Let T2 equal T RET, T ret, be the clock reading when the photon arrives at C. The distance is covered with the speed of C. We have that T minus 2 minus T minus 1 equals T ret minus T minus 1 equals L over C. And then we have reduction of that in equation 6, 7. The total time elapsed is given by equations 8 through 10. Since the first order is 1 minus beta equals 1 over 1 plus beta from equation 10, we have the finalized form here given by equation 11. Time equals 2L over C plus C times 1 plus beta. Thus, the Newtonian result coincides with the relativistic one. Now the question is, where do Saproveri and others see the inconsistency? According to them, since the frame S minus, the photon was at B in the past event E. What is it when there's 3 equal signs? That just it extra
Equivalent
equals it?
to.
Equivalent
Yeah,
to.
basically.
E is equivalent to the clock turning around the point A in the frame S minus at T minus equals 0. We have the missing part from the section AB L in that frame. The missing part would correspond to the distance the photon traveled during the past of the event E. The idea seems to be that it is impossible or absurd that the photon traveled that distance in the past of E. Therefore, it had to jump from B to the position of the corresponding E minus equals 0. However, it is true only if we assume that the photon was not indeed at B in the past of E, the frame S minus, which merely means that we are rejecting the relative character of simultaneity between the frames in relative motion. In other words, Saproveri and others' reasoning reduces to proving that relativity of simultaneity leads to inconsistencies by assuming that it is inconsistent. Their reasoning can be considered a more elaborate case of Einstein's train embankment thought experiment. Einstein conceived his example to show that if we are to accept the existence of invariant universal constancy of the speed of light, we must jettison the absolute character of simultaneity of distant events. Similarly, the authors of citation 4 prove that an observer moving with the clock cannot measure the speed c unless the event's e is not simultaneous with the event photon at b in S minus. Thus, they present another proof that the invariant universal speed and absolute simultaneity at a simultaneity of distance events cannot stand together. From a purely logical stance, it is possible to deny relativity, but we have to reject its postulates from the start. However, it is pointless trying to prove the eternal inconsistency, i.e., once we accept the premise, they do not lead to contradictions, or at least none so far as we were able to find. The ring interferometer. We shall prove that the correct application of the relativistic formulas gives the invariant speed of light equal to the universal constant c for observers within the rotating platform, and that puzzling time gap is a natural consequence of the relativity of simultaneity and has nothing to do with the alleged
Oh,
impossibility of synchronizing a clock with itself or with time being discontinuous.
Dude,
Doing the,
hold on a minute.
Go
Hold
ahead.
on. We shall prove that the correct application of relativistic formulas gives an invariant. Dude, the correct application of like this is what they're going like. Oh, it's always the same garbage, man. I just this that sentence is so gross. We shall prove that the correct application of relativistic formulas gives an invariant speed of like who cares what the formulas give? Just explain it.
Well, do you have the correct interpretation yet? No. Look at this formula. Do you have it yet? No.
Always
There's
the
another
same
formula.
thing. It's always the same thing. And it's like, like I always say, I don't disagree. Like it's great math. The math works out. I get it.
They're like, you
But
don't
I'm
get it.
just
You must
saying
not get the math.
the
Hold on. Let me
math
show it to you again.
is useless because it's a higher order than the classical mechanics. Oh well.
It
I know
sounds like
I
you
know
just
we've
don't
gone
get
over
the
it a million
math.
times, but that is just such a gross sentence, man.
Yeah, it's my least favorite sentence.
Like, yeah, from gives rise to an invariant speed of light from the like for observers within the rotating platform. Like as long as they're within like a perfect like it's invariant. Doesn't really matter if they measure it as variant, but it's invariant for them within that rotating, not actually for anybody in real life, but it's for them
Well,
in that
theoretically,
one particular geographically convenient position.
like if you were to do a thought experiment and put yourself in that specific frame, then yeah, you could be said to have existed in that frame.
So gross, man.
I'm so confused, bro, by this. It
So,
says invariant
What
speed
up,
of
Kai?
light. So what's up, bros? Invariant speed of light C for observers within the rotating platform. Okay, so how's there a time gap? And it says it's a natural consequence of the relativity. That doesn't make any that's not coherent. I don't what? If C is C and
Because
it's a
they're dude. It's the same thing as always. It's because you're not playing the game. You're not taking
Well,
the relativistic frames into account. You're not thinking
yeah.
about different people in the platform, all just interpreting it through. They can measure it with perfectly classical mechanics, but you're not playing the thought game. They all are actually interpreting literally different realities.
You
well
actually
it's
have the incorrect interpretation right now. You have to get the correct interpretation, and then you'll know. You missed the preface, dude.
well, there's like a bait and switch. There's like a sly slip in happening here because they're saying
No.
it's due to the relativity of simultaneity, right? It's saying this like simultaneousness, right, is relative to you or you or you or you. Okay, but in the case of the rotating platform, they're all co-moving, so simultaneity is not relative to them, it's absolute. They all experience everything simultaneous as long as they're co-moving. So just making that statement, just saying those words doesn't make any coherent sense because simultaneous events would be simultaneous for all the observers on the rotating platform that are co-moving. There wouldn't be any relativity of simultaneity for them.
What I think you're missing is that paradoxes are eloquent and intriguing and a little bit mystical, and only smart people can use them. So you must not understand it because you didn't dazzle with the paradox.
Over your head, yeah. We get it, you don't. Sorry, buddy.
We're trying to get the correct interpretation here. Did you know there was a correct interpretation, PSO?
yeah, I think you're just incorrectly interpreting it or whatever. They're going to explain the mysterious time gap puzzle, dude. PZO, do you think they're going to try and say that the beam split was like a not simultaneous event or something?
I think maybe they're gonna say that if you invoke a position somewhere else, that it wouldn't be a simultaneous observation that would explain the time difference. I don't think they're going to do anything to explain the time difference located locally on the co-moving, rotating device. I don't think that
Popcorn,
they're going to
anyone?
say.
Oh, sure, yeah. So we got section 3 here right at the top, right?
Yes, sir.
Or no, that's the gross sentence. So yeah.
Yeah,
Um,
I read the gross sentence for you, so
doing
you didn't have to, and you could start here.
Oh yeah, I'm sure it's gonna get a lot better now. Uh, doing this correctly requires the use of the formalism introduced in general relativity. This does not mean that we need gravitation theory to describe non-inertial systems. The last point is a widespread misconception. Oh, is that so? Yeah, I've certainly have been argued that misconception
Oh,
numerous
yeah.
times.
Yeah, we're definitely gonna read about that after this. Go ahead.
So, as Pepino and Mabille recently pointed out in citation 8, to avoid possible misunderstandings, we clarify that the following formalism is based on the validity of the what is LT?
Lorentz transform.
Ah, perfect. Okay. On the validity of the lens transformation and the application of the special relativity through the principle of locality, citation 9. The need of the general metric formalism is necessary because when we pass to a non inertial system, we need general nonlinear transformations y to the power of, what is that, mu?
Yep.
Equaling y to the power mu. And then what do we have? A series of x0, x1 through 3. And then the Minkowski metric and becomes this guy, equation 12. Looks like we've got some very fun stuff going on there. What the
This
heck?
is the curved space-time metric, and then these are
Ah, there we go. There she
derivatives.
is. Okay, yeah.
Yeah, and these are
So there you
derivatives
go.
of
That's
the
how that,
coordinates. So
there's your equation. That's how you,
they're
holy
taking
cow.
curved space-time and they're making little flat segments.
Reminder, those are not just, ratios or whatever, this is, we're going up to higher orders, and we've got variables in our orders there. Is that what's going on?
Oh yeah, we're going full abstract, dog.
Pretty cool. The metric tensor components, G mu vu, become functions of the space-time coordinates. We assume
New.
that the Einstein nu,
Th-
thank you, G mu nu, become functions of the space-time coordinates. We assume the Einstein summation convention. Greek letters indicate space-time indices varying from 0 to 3, while Latin indices are space indices ranging from 1 to 3. The interval ds in a non-inertial frame can be expressed
It's
as
ds
this big
squared.
guy. The old ds squared. It is so perfect. It's so perfect. And just look at that. Like, mm, 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 mm. Just bow down and worship, guys. Equation 13, 14, 15, 16, 17. Just where GI equals negative GOI over goo. GOO. The
Or
quantities,
goo.
the quantities psi x to the power of O, or psi, or what is that?
It's delta x
What
naught.
is that? Oh, delta x naught. Thank you, sir. And gamma ik has relevant physical meaning. The 3 tensor gamma ik determines the geometry of space with respect to the non-inertial frame, while the quantity gamma x naught, or sorry, gamma x naught is the synchronized,
Delta.
sorry, right? Delta x naught, my bad,
The
is the
lowercase del.
synchronized time, huh?
The lowercase delta.
Was it?
Instead of like a triangle, you get this. It's delta, but just a
Oh,
different.
yeah, the other guy, the lowercase, yeah. Is the synchronized time interval. We can look at references 10 to 12 for that. As is well known by relativists, in a non inertial frame, the geometry of space can be non Euclidean, notwithstanding that we are dealing with flat space time without gravitation. So we're doing flat space time.
Yep. Yeah. So when they going back to here, they started with curved space time with with no specifics to it. So like no mass or anything to cause any curvature. They just have like the curved coordinate system here. And then when they take the derivatives of it, they're just like taking like infinitesimally small pieces of the curve. So it's just essentially super flat.
Ah, okay. Thank you. Where were we? Okay, without gravitation. Furthermore, synchronization of clocks, as in inertial systems, where all clocks can be set to show the same reading simultaneously, is in general impossible inside a non inertial system. The proposed or the proper elapsed time indicated by a physical clock in the same point of space within the non inertial frame is d tau equaling the square root of goo, G naught naught, over square root of goo over c times dx naught. However, owed to the lack of synchronization of clocks in different points of space, the elapsed time as marked, or the elapsed time as marked by two different neighboring clocks is delta tau equaling square root of goo over c times delta x naught, being not equivalent to, or not equal to the, which is not equal to d tau, I suppose. D not equal to d tau being the tau. Okay. Can you scroll up a little bit?
Or did you
Okay.
mean good?
We're just talking about clock syncing. I'm just trying to follow, but it's I'm not gonna. I'm getting gooey here.
Getting gooed up.
Velocities getting gooed up. Velocity should be calculated with equation 19, not with equation 18. You can look at reference 13 for that. And in particular, the speed of a given particle is v equals dl over delta tau. Not the usual formula dl over d tau used in inertial systems with globally synchronized clocks.
Not to
So,
be confused with the absolute
playing a bit.
fucking system that
Yeah.
they use. This is so crazy, dog. Pain's almost over.
Section 3.1, the speed of light in a rotating platform. So we're gonna not read all these
Oh
equations.
no,
Using
yeah,
cylindrical
here
coordinates.
it's already over, dog. They're already invoking.
Well, yeah. You're not excited about this? You don't
Dude,
wanna set up the this is it. Dude, we're setting up our geometrically convenient
dude,
position. Why don't we
it's
set it up?
it's so funny how like people that will read this and they're like, "Oh yeah, this is explain it." It's like after this, we're gonna read the exact violation from Einstein himself to see how
Oh
ridiculous
yeah.
this is, and like the preface that it's like, "Oh, well, this actually falls under general relativity," is such a cop out, dude, and it's all in related to this because
Wait, I
nobody can
thought the argu
explain this.
Ugh, this is so stupid. I thought that actually it's funny because we started diving into all the GR, and then like I thought I thought we were not gonna do GR. I thought they said they weren't gonna have to do this,
No,
but okay.
no. So what he said was, "Hey, we don't need no GR for this, but let me grab some abstract coordinates from the curved space-time metric real quick that are infinitesimally flat, and then we'll invoke a geometrically
Mhm.
convenient position here to utilize these coordinate systems. Because now that we're in the general theory, I mean, when in Rome,
Okay, let's
right? So,
here's
dude,
what I
this
will
is so
say.
crazy."
This is crazy. This is really crazy. But I will say this is the proper argument from a relativist at this point in time. Is it
It's the
not?
it's the only way that they could do it, and then
It's the
deny
only
the
way.
fact that they're and then just deny that they're violating the 1905 paper. It's
Oh,
the only way.
dude. Look at that.
Notice how
How could
he
you defend that?
yeah.
That's insanity.
Yep.
All this so you can say that what you measured in reality is not reality.
Cool. Pretty neat. Yeah, so let's not. So then we'll just skip through here. Using cylindrical coordinates in an inertial frame with an origin at the center of the platform, we get equation 21. We perform a transformation to a frame rotating within the platform, equation 22. In the rotating frame, the interval is equation 23, where we have this equation, and that values of gi and gamma ik are equation 24, equation 25, equation 26. The null geodesics giving the light paths on the rim of the platform is obtained by setting ds equals 0 in equation 23. But then we're going to go through equation 27 and equation 28 and applying the correct formula for the speed according to equation 17, 19, 20, 24, 26, and 27. We get equation 29, 30, 31, 32, and 33. Similarly, we can prove that dl minus over delta tau minus equals c, constant speed of light. Thus, we correctly apply the relativistic formulas with the appropriate formalism. We find that the observers in the rotating platform measure with their physical instruments, clocks, and rulers the correct invariant value of the speed of light.
What
See?
the ruck?
As a further as a further consistency test. Don't worry, we're gonna do a test. We're gonna run some checks here. As a further consistency test, we can calculate the total times t plus and t minus that take for both light rays to complete a closed path around the platform according to the observers inside it. The time must be calculated by summing the actual corrected time increments along the path. We get equation 34. Look at equation 35. If you're not impressed by that, look at equation 36, and then we got equation 37 to sum it up. According to equation 26, total length L plus of the closed path is L plus equaling the integral of dl equaling yeah, there you go. Equation 39. This the mean speed along the closed path again, L plus over t plus equaling c, constant speed of light. Similarly, it's equation 40, equation 41. If you're not impressed by that, look at equation 42, and then we've still got equation 43. Since L minus equals L plus, we also have L minus over T minus equaling C, constant speed of light, for the clockwise beam. Thus, the mean speeds, when correctly evaluated, also coincide with their local value C. One could still think that we have a paradox here, because, as is well known, the clockwise and counterclockwise beams do not arrive at C simultaneously. But that is also easily explained because the desynchronizing effect is different in both directions. So there you go.
Dude, these people are disgusting, bro. Literally made C equal C in the frame. And then now he's like, there might be a problem here explaining the fringe difference, but whatever. It's to be easily explained.
They did it. Hey, there you go, guys. There you go. The desynchronizing effect is different in both directions. So there you go. Bim, bam, bada boom. Anyone want a popcorn? I don't mind finishing up.
Yeah. If you want to, we got.
I can keep going. All right.
Send it.
Clock synchronization in a rotating platform. This is perhaps the only point on which we partially agree with Spavieri and crew. They claim that relativity implies an inconsistency arriving from the synchronization of distant clocks. Next, we explain that the alleged inconsistency is only a consequence of the inappropriate definition of simultaneity that sometimes is given. The simultaneity of distant events and synchronization of distant clocks cannot be consistently defined in arbitrary reference frames. Wait, what? Specifically, the case that concerns us here is that of stationary fields. A gravitational field is called constant if the components g, mu, vu are, g, mu, vu, correct?
G mu nu.
Nu, my bad. G, mu, nu are independent of the time coordinate x naught because the cross terms goi equals oi. Or GOI equals GOI.
Yeah. Goi equals goi is exactly what it says.
The field is called static. Otherwise, they are called stationary. The same classification applies to the metric field G mu nu. when we are in flat space-time without gravitation. Wait, so the same classification applies to the metric field G mu. Okay. In a rotating platform, we have, according to equation 24, G O rho not equaling 0.
Goofy.
Goofy? Go phi?
Yeah.
Go phi is not equal 0. We must go phi. So we must be careful when defining simultaneity of distant events. We can always define simultaneity for infinitesimally near points. The difference of coordinate time delta x naught that correspond to simultaneous infinitesimally near points in space is given by delta x naught in equation 17. The fact that delta x naught is not equal 0 for simultaneous events simply means that clocks cannot be assumed to be synchronized. What about simultaneity of distant events? Here's where the confusion arises. Because some authors define simultaneity of distant events by integration of the infinitesimals concept, you have equation 44 there. According to equation 44, we have that x naught a and x naught b would be the time labels for simultaneous events at a and b. Since in general we have that equation 45, and so scrolling down there, Spaffieri and other authors, citations 4, 5, and 14, have correctly pointed out such definition leads to the obvious inconsistency that a given event would not be simultaneous with itself. Therefore, relativity is inconsistent. As we mentioned at the beginning of this section, the problem does not reside in the theory, but in the incorrect definition of simultaneity according to equation 44. Indeed, any inconsistent definition of simultaneity requires a property that equation 44 lacks, namely transitivity. Really, we have that in general.
Transitive.
Dude, we're going to a new level here, dude. We're going to a new level.
Dude, this is nuts.
The language of relativity, man. This is yeah, they call it physics, but it's its own esoteric language, man. That's what this is. Like, is it not just an esoteric language of its own? This is insanity. So there you go. Equation 46 means that if A is simultaneous with B and B is simultaneous with C, there you go. Then A is no longer simultaneous. Let's just pause on that. It means that if A is simultaneous with B and B simultaneous with C, right? So A is simultaneous with B, B is simultaneous with C. So just think of this.
Yeah.
You guys with me?
Yeah.
Well, then A is no longer simultaneous with C.
Oh, shoot. I thought I had it.
Thought you had it, didn't you? There is one case when equation 44 can lead to a consistent definition of distant simultaneity. It is when the integration path is independent. In those cases, we have that the G, taking the limited G, I guess, equaling the negative, what is that, the nabla of the function. However, in such cases, it can be proved that a change in the time coordinate x prime naught equals x naught plus the function of x to the 1, x squared, x cubed, leaving invariant space-time coordinates leads to g trending to equaling 0. So we are indeed in a static field, according to equation 13. In the case that concerns us, i.e. the rotating platform, equation 47 is not verified because look at these partial derivatives in equation 48. Equation 48 simply means that the concept of distant simultaneity does not make sense for, holy cow. So equation 48 with all, simply means that the concept of distant simultaneity does not make sense for observers within the rotating platform. So you were there, you saw it, it just doesn't make sense for you. Maybe you just don't get relativity.
Conclusions. Oh, I can't wait
Sweet.
to see what they've drawn from all the from 10 pages of this.
We have proved that the alleged inconsistencies and empirical. Wait, what? Wait, what is this? We have proved that the alleged inconsistencies in empirical evidence that the Sagnac effect presumably reveals presumably. Okay, here we go. So they're presumably reveals against relativity theory are based on incorrect applications of the theory and the use of erroneous definitions. Regarding the modified Sagnac experiment of Wang and crew, the explication is no more puzzling than relative simultaneity itself. If you don't get it, you just don't get it. So it can be considered inconsistency proof it cannot be considered inconsistency proof unless we declare relative simultaneity inconsistent. We can't do that, obviously. This type of circular reasoning is typical of arguments trying to find internal inconsistencies in relativity theory. As long as the relative nature of distant simultaneity does not lead to observable or logical contradictions, its absolute character shall remain a forsaken relic of our past metaphysical prejudices. Whoa,
Wow.
boy.
What a complete toilet.
Who did we just listen to? That was maybe the worst one yet.
Dude, that was worse than Tartaglia.
It's like I applaud the orators, like the writing skills quite heavily. Like that's pretty impressive to be able to do what you just did, but man, oh man, that was pretty gross.
Super yucky.
Can we go back to the time? Who was that?
Who's who?
Who wrote that?
Oh, this would be
Basically the top of the paper.
Yeah, this would be the boys. Yeah, whoever these guys are.
Paraguay.
Yep.
I hope they get a big raise or whatever.
Your boy Justo Pastor Lambre.
I'll say is the best one. If I'm on their team, it's the best one yet.
Really?
It's the grossest one yet. It's the grossest one yet. It's holy cow, that was disgusting.
I'll take a Tartaglia over this one. At least Tartaglia.
Tartaglia is funny. He kind of just sneaks it in. He gets all the pretty diagrams going.
And then he just throws in a gamma factor at the end. And he's like, look, boys, I gammed it in there. But yeah, all right. So we're going to read the rules real quick of relativity theory and see why these guys are sweating so much. So this is Einstein's 1905 paper on the electrodynamics of moving bodies by Einstein. All right, so let's see here. He goes on to say he's laying out the premise and postulates for his theory and what it's all about to be about. So he says examples of this sort, together with the unsuccessful attempts to discover any motion of Earth relatively to the light medium, suggest that the phenomenon of electrodynamics, as well as mechanics, pose no properties corresponding to the idea of absolute rest. You know, irrespective of the fact that the laws of physics are all derived here on Earth, they all apply here on Earth in the old inertial frame. And then that one paper from Engelhardt where he's like, you know, there's a non-inertial frame. Like, where do the laws of physics not apply on the Earth again? Okay. So, you know, they just have this like inherent philosophy that it can't be the Earth, right? Like Newton's bucket, they were like, where's the rest frame? The stars, you know, not on Earth. Just the furthest thing possible that you can never get to. That's where rest is at. It's not where I'm standing spinning the bucket. No, that's preposterous. They suggest rather that it has already been shown to the first order of small quantities, the same law of electrodynamics and optics will be valid for all reference frames for which the equations of mechanics hold good. So if you're in an inertial frame at rest, you know, or at fake rest as defined by these people, or if you're moving at a constant velocity, Newton's equations hold good, and you can apply what Einstein's going to put forward in these frames. So then he goes on to say, we raise we will raise the conjecture, the purport, which we will hereafter call the principle of relativity, to the status of a postulate. Ooh, he's raising his conjecture to an ingenious conjecture. He's just conjecting it harder. That's fucking badass, brother.
Well done, man. So dramatic about it too, right?
And then on top of that, he's not just gonna introduce one posty, boys. He's going for the double posty. So he's gonna hit us with another one, another ingenious conjecture, which is only apparently irreconcilable with the former, namely that light is always propagated in empty space with a definite velocity c, which is independent of the state of motion of the emitting body. And he isn't saying anything new here with this. What he's actually saying is that also the observer moving at a constant velocity, it's independent of that as well. So he's not, because everyone knows that the waves measure, that the source of motion doesn't affect it. It's the observer. So it would be the motion of the observer. So that's what he's talking about here. So these two postulates suffice to attain a simple and consistent theory of electrodynamics of moving bodies based on Maxwell's theory for stationary bodies. The introduction of a luminiferous ether will prove superfluous, inasmuch as the view here will be developed will not require an absolutely stationary space provided with special properties, nor will it assign velocity vectors to a point in empty space in which electromagnetic processes took place. Okay. So the idea that we can, where did he do it at? Down here at the end where he snuck it in. He waited till the end. Okay, yeah, right here. Using the cylindrical coordinate system in an inertial frame with the origin at the center, right? So he sets us up for a transformation to be at the center where he can assign velocity vectors to a point in empty space where electromagnetic processes took place. That's the only way that they can do this, and that's by violating Einstein's postes. Remember right here in 1905 when he was like, yo, boys, we don't need to do that or assign any velocity vectors to empty points in space, right? Then he goes on to talk about relativity of simultaneity here for moving observers and whatnot. And he's saying that the way he lays it out, he gives out like an example where he's like, yo, if I tell my buddy to meet me at 7, he knows what time 7 o'clock is. But if I said that to somebody who lives in Africa, they would have a different conception of what 7 is, and it doesn't mean the same thing. So he's literally saying that in the coordinate systems where you're doing Lorentz transformations, the coordinate time in the stationary frame is physically not connected to the tau time in the moving frame, which is the proper time, which is going to be experiencing time dilation as a function of the square of the velocity over c squared. In that frame, he's saying that if a simultaneous event occurs for both observers, the moving frame, it won't be simultaneous in that frame. Now, obviously, there will be an apparent Doppler shift, and the event might not appear that way. But in reality, right, the lightning strikes at two different spots at the same time. That's what actually happened. But the way that Einstein has to argue it is that because the time is not continuous and it's infinitely disconnected into little segments arbitrarily defined by a coordinate system, that the event actually didn't occur simultaneously, right? That's what leads to the bomb paradox and all these things. And when you add physical consequences to it, nobody wants to play. But when you're just using a train embankment, it's very fascinating. So he's laying out that whole preface there, and then we'll read a little bit more on simultaneity here at the end. But here he's showing when you start to add velocity to a time difference, the normal way you would do it, like using absolute time for like a Galilean transformation, so t prime equals t and all that. He's saying all of that stuff will lead to inconsistencies when you start adding motion to it, and he does that in this section right here. Right, he shows that when you add velocity, the times will no longer be equal between t prime a and t prime b, and that's where he's like, okay, well, how do we solve that, lads? Let me introduce you to Voldemort-Voigt's equation that I ripped off. And this is the beta equals 1 over the square of 1 minus nu squared over c squared. And this is where he introduces the Lorentz transformation, which is also the Voigt transformation, based on the same principles, that he raised to an ingenious conjecture. We have the time coordinate being a function of the square of the velocity over c squared, and the x coordinate distance, contracting at that same proportional rate. So these are discontinuous timelines that they're transforming from. They're not connected. And then further, the whole debacle on, okay, well, we have a rotating interferometer, dude. This is a non-inertial frame. No. So here's what Einstein has to say about rotation. And if a clock at A is moved with the velocity nu along the line AB to B, then on its arrival at B, the two clocks are no longer synchronized, but the clock moved from A to B lags behind the other, which has remained at B by 1/2 t nu squared over c squared, t being the time occupied by the journey from A to B. It is at once apparent that the result still holds good if the clock moves from A to B in any polygonal line, and also when the points A and B coincide. If we are to assume that the results proved for any polygonal line is also valid for a continuous curtly curved line, we arrive at the results. If one of the two synchronous clocks, blah, 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 then he goes on to say that they'll be desynced by this factor here, 1/2 t times nu squared over c squared slow. And he's not talking about a like a pendulum. He's talking about a light clock, so an atomic clock, but this is before they had atomies. He's telling us that in the rotating frame, his equations still apply, right? So, and this is like double true because of what's it called? Rapidity, right? So we've talked before about how they apply Thomas precession, how they attribute that to special relativity, right? And they do that through establishing rapidity. So if you take two infinitesimal, points in time of a circular rotation or circular orbit or whatever, they won't be. Let me draw this out 1 second so it'll make sense. Oops.
Ooh, pulling out the Excalibur, huh?
Yes, sir.
Nice. You were doing some artwork earlier, huh?
No, so I set up this thing to have a thing where I could do notes and then have it be associated with a picture, and you swap in between them. But then I never followed through with it or use it for anything, and somehow it saved a squiggly line that I made when I was setting it up. So every new Excalibur has that in it. Okay, so let's see here. Let's do this. Yeah, actually, let's do a circle, and then as the circle's moving, so we have. Oops. Well, just imagine that's a perfect right angle, right? And then we have another time that we're defining here. Okay, well, now the right angle is off a little bit. So what they can do is they could establish the angle between these two, and that's called rapidity, right? So they get a nice little theta out of it. And that theta angle will align these two frames. And when you have two frames that are orthogonal to each other, you can do a Lorentz transformation. So the idea that you can't use a Lorentz rotation to establish a Lorentz boost is retarded. If somebody tells you that a rotating frame is a non-inertial, a uniformly rotating platform is a non-inertial frame, and special relativity doesn't apply, remind them that rapidity is used. This angle right here is called rapidity. This is used to establish the correction angle for these two frames to make them orthogonal, right? To make them nice and orthogonal to one another, so you could do the linear transformation. And then on top of that, you can also do integrals of it. So it's just basically you can just, without even doing any of this, you can just math out infinitesimal sections of it. It doesn't matter at all. It definitely applies. The reason that they say it doesn't apply is because of Sagnac. So let's see. Yeah. EPS 4.
Stuff they get away with. mean, it's a pretty straightforward explanation, but I don't know how they the rotating platform thing is crazy, man.
Yeah. So here's a better diagram of what I was showing earlier, right? You see how they're not, orthogonal to one another perfectly. Well, you can just correct that with that theta angle, and then you're good to go. So two of these gives you a Lorentz boost, or it sets you up for a Lorentz boost, which is where relativity theory applies. And Einstein even tells you so much in his paper, right? So if people are going to argue against that, they're just being absurd and they're arguing it against the established literature.
So, wow. Wow, nice breakdown. I always like it's BS always calls it a bug in the software, right?
Yeah.
He always calls it the bug. Like, here's the bug. And that paper has so many bugs in it. And uh when you think about the paper we were looking at right before that, that's the result of all those bugs. Like the software or whatever you want to call it, like special relativity, like 1905 paper, it doesn't work. It's written with bugs. It doesn't even like boot. It doesn't do anything. Like it's a broken theory. And all that other crap we were looking at in that other paper with those partial derivatives and like 67 equations with, like going to, infinitesimal orders or whatever, or infinite orders or whatever, like, um, that's just,
Not adequate.
it's just like, it's, it's to cover up the fact that the software is not doing anything, right? Like, that's very important, very crucial. Maybe if anyone actually followed all this and doesn't already understand, then I guess, I don't know, like, that's kinda crazy. But if anyone's actually listening and doesn't realize, like, this stuff that they're proposing, like, their arguments, when you take out the classical mechanics and you start using the special relativistic explanations, there is no predictive power there. It's all just a relative, like, the relativistic explanations are postdictions. They happen after the fact. It's after the experimentation has already been done. They then do the math and say, "Oh, we can now explain this with a Lorentz transformation." Or in that case, a bunch of general relativistic math. Like, we can do this after the fact. There's no predictive power there. The predictive power lies in very simple, like, classical mechanics, as in the speed of light, quote unquote, is moving at the speed of light. And then also, in addition to that, if it's being received at a certain speed, then that's going to be relative. And it's the same thing with the emission speed, but especially with the reception speed. And that's why with you know with the Michelson-Morley experiment, you would have actually detected motion if we were in motion. But yeah, it's all to cover that up, and there's no predictive power there. So just keep in mind that that's what we're looking like. That's part of why we get so grossed out when we read all that, because we know there's not even anything useful underneath all of this. It's all just to cover up the fact that there is a very simple predictive power in the classical mechanics. And we see the results, they're read actually in reality in the lab frame, is what we always say. What always mean when we say the lab frame is it was measured, like it was experienced, which is crazy. Like, you shouldn't have to distinguish that this was actually tangibly manifested in reality for us to actually have to count it, right? Like, we shouldn't have to differentiate that. Oh, well, we're actually looking at measurements. You guys are only looking at abstract math that has essentially no grounding in reality. And actually, the one place where it does ground into reality, the one notch that you've got, the one little tether you're building in, as Alan just showed, violates rule number 1, page number 1 of the 1905 paper. So you actually have no way to even do the math that's philosophically sound in the first place. But even if we were to grant you the math, you have no physical explanation. It's just it's frankly very gross. And so, yeah.
Yep.
Is that everything we had for tonight?
Yeah, that's
I
all
mean,
I
obviously, if
had.
anyone else wants to
That's all I
chime in or
had,
has any
really.
thoughts.
I love the gross sentiment.
Yeah, I don't know how else to put it. It's just it really it makes you feel kind of violated in a weird way.
I mean, like I could dress it a little bit, and we could call it fucking gross.
Yeah, yeah. Well, cool. Thanks everyone for listening in. I think most people listening probably know you can always go to brushtail.coffee, brushtailcoffee.com, and you can order my coffee there. I roast it myself. And yeah, I am proud of the coffee I roast. It's pretty good. And then tomorrow night, I'm imagining there's probably a Flat Earth Fridays going on. Alan will be over there for that, right, Alan?
Yes, sir. Episode 111.
Dang, there you go. Episode 111. Anything else we wanted to talk about? Anyone else have any final thoughts? Oh, and also everyone should check out Tuesday's stream. It was, if anyone happened to have missed it, go check it out. It was pretty awesome. Bennett had a lot, or Cassandra had a lot to say, and definitely worth. I need to go re-listen to it because there was a lot of golden nuggets in there.
So much knowledge and
But yeah,
wisdom
thanks
in
everyone
it.
for listening in. What's up?
I said so much knowledge and wisdom in there, and good advice for debates and just future conversations.
Yep, exactly. Yeah, it was a really good one. We're super thankful he came by and spent so much. Man, he hung out late. He hung out for like 4 hours or so until like midnight. That was awesome.
And
But
then,
cool.
yeah. So next Tuesday,
Wrap them up.
Yeah,
Oh,
next
go ahead.
Tuesday we have Shane presenting on maps and coordinate systems again. He's going to do a nice truncated breakdown of everything that he's been working on the last couple of months in regards to all the coordinate systems and maps and stars and transformations and what it all means. And of course, the Grady is involved in there. So shout out to the Grady. So Shane's going to be breaking that down on Tuesday. So tune in for that.
It's gonna be cool. Kind of more celestial sphere though. I already did all the map stuff. I expect everyone has that down. I guess
Oh,
we
yeah.
could touch up on it for sure, but definitely
Yeah.
more celestial sphere, old school tools, and yeah, melded them together.
Right. So I
Very nice.
said the wrong combination of words there. I meant celestial sphere.
Oh well, they're kind of the same, right? So I mean, like, they're not technically wrong.
Yes. All right.
The best,
Cool.
the best kind of right.